Okay, so for this last video for chapter 6, what we're looking at is solving systems another way, and that's by elimination. So it's a little complicated, but elimination means to get rid of. So when you're doing this kind of stuff, what you have to do is you have to first off make sure that the two equations or the two conditions are in standard form, which that would be ax plus by equals c form. So in this first one, this first example, they are, and then what you want to do to eliminate is you want to see alternating signs either in front of the x or in front of the y. So if we look, we don't have alternating signs in front of the x. What I mean is, look at the two x's. 2x is positive and 6x is positive. But if you look at the second part, the plus 5y and beneath it is the minus 5y, they have alternating signs. That's good. So all we do is old school addition. What's 2x plus 6x? That's 8x. These guys are 0, and 17 minus 9, I believe, is 8. And then you solve this. So x equals 1, right? So now what I do is I go back and I pick either condition, the first one or the second one. I don't care. You substitute in that 2x, or that 1 for x. So 2 times 1 plus 5y equals 17. So now you have 2 plus 5y equals 17. You take away 2, you take away 2, you have 5y equals 15. You divide by 5, you divide by 5, and you get y is 3. So the intersection is 1, comma 3. And if you solved both those conditions for y, you'd get the same thing. So when you're doing what is the solution to each system, use elimination. The part A, you can see right here, you have alternating signs, and the y's go away. On this one, because it's 6, negative 6y, and positive 6y. On B, you have it for the x. Just make sure when you solve it, you plug it in for the right variable. Okay, so give those ones a shot. We'll talk about those tomorrow. Another thing you could do is, it says solving a system by subtracting equations. The theater club sells a total of 101 tickets to its first play. A student a student ticket costs $1, and each adult ticket costs $2.50. Total tickets are $164. How many student tickets were sold? So if you let X be the student tickets and Y be the adult tickets, then you can do this. X plus Y equals 101, and then you know that the student tickets was $1, so 1x plus 250y equals 164. Now this is where we have a problem. We don't have alternating signs. So what I'm going to do, I'm actually going to multiply this top one by a negative. I'm going to multiply this top one by a negative 1. So watch what I'm doing here. I get negative x minus y equals negative 101. And then I just bring this guy over. Now I have 1x plus 250 y equals 164. Now it wouldn't have made a difference which one I chose, but I chose the top one just because. X's go away. I get $1.50 y because I take that away equals 63, and then I divide both sides by 63. Or I divide 63 by $1.50 and I get 42. So 42 of the adult tickets were sold. So then I go back here and I plug it in and I just do 101 minus 42, right? That's 9, that's 11, so that's 9. So 89 kid tickets were sold. Okay? Or not 89. How many student tickets were sold? You do 101 minus 42. Oh, 9, that's 59. I have a problem adding. Sorry. So 59 is what was sold. Easy enough. So for yours, I would have a variable for cars and trucks. Okay, for cars and trucks here, and to see what you can do on that one. Another example. Sometimes you got to multiply. Sometimes you got to be a little creative. So on this guy right here, I'm looking at find what's the solution. Well, you have to ask yourself, do we have alternating signs? And yes, we have it for the x's and we have it for the y's. So which one are we going to get rid of? Well, I try to get rid of the y's all the time. So if I'm looking at it, I got 15y and I got negative 5y. If that was a negative 15y, I'd be golden. So what I'm going to do is I'm going to multiply this bottom row by 3. So what I have here now is I now have negative 2x plus 15y equals negative 32, and I have 21x minus 15y equals 17 times 3. What's 17 times 3? Well, I don't know. So put it off to the side. There's 1, 3, so 51. Now when I add them together, that's 19x equals 51 take away 32. That's 19. So x is 1. Now I'm going to take that x is 1. I'm going to plug it back into my original system. So I'm going to go 7 times 1, which is 7, minus 5y equals 17. So I subtract 7, I subtract 7, I get negative 5y equals 10. Divide both sides by negative 5, so y is negative 2. So this intersection is at 1 comma negative 2, right? So when you do the got it, you do the same thing. You just go ahead and try to figure out which one you want to get rid of. In this case, either one works. It's completely up to you. You know, if you want to get rid of that one, I don't know. I would probably actually, this isn't the guy. This is another one right here. On this one, you might have to multiply, but like I'm going to get rid of the y's. So I'm going to multiply this by a negative 2 and then this one by a 3. So I get 9x plus 6y equals 3, and I get negative 8x minus 6y equals positive 4. Then when I add these guys together, excuse me, I get x equals 7. That's easy enough. Now I go back and plug it into the original condition. 3 times 7 plus 2y equals 1. So I get 21 plus 2y equals 1. Subtract 21. 2y equals negative 20. So y is negative 10. Okay? On how many solutions does this system have? That one we're actually going to talk about in class. We'll talk about the types of solutions. You either have one solution, no solution, or infinite solutions. So hopefully this makes sense. I'll see you in class soon, and may the force be with you.